Hello everybody, my name is Sadek. Today I'm going to show you how can we measure the absorption of gamma radiation. As you know, disintegration of radioactive element produce three types of radiations: alpha, beta, gamma. However, they have different features. In this case, we just only investigate the absorption of gamma radiations. So a theory behind the experiments: as you know, gamma radiations is very short wavelength radiomagnetic that emitted from different nucleus sources. So, for example, cobalt-60 or cesium-137, they can emit gamma radiations. So, as you know, gamma radiations, they don't have a definite range in material, and they are attenuated based on exponential relations. So the equation that we are going to use today is equation 1, where actually n is equal to n0 e to power of minus micro x. So what are the elements of these equations? N0 is the number of photons incident on the matter. N is the number of remaining after penetrating in a specific thickness, so which is x, and the unit of thickness should be centimeter. And then macro, which we are going to calculate today, is the linear attenuation coefficient. So by taking a natural logarithm of our equation, we can have these equations, and then finally the final equations is actually n divided by n0 is equal to minus micro x. By plotting n divided by n0 against x, then we have a straight line, and the slope of that line should be the linear attenuation coefficient. So we are going to show you actually how the prac work. So here we have the requirement for our experiments. We have a vernier caliper for measuring the thickness of three absorbers that we are going to use today. So they are lead, glass, and aluminum. So we have a radioactive source, which in this case is cobalt-60. Just remember to handling safely the radioactive source. If you have any question about the health and safety, just come please and ask us about it. We have a Geiger-Müller tube here, which measures the number of count of, or the number of photons per each 30 seconds. So the Geiger-Müller tube is connected to a laptop, and here we have a software for measuring the count or the number of photons. So we have three types of measurements. The first one is we are going to measure the number of counts for as a background, and so we repeat it for 3 times. And next one is measuring the sources radiations without using any absorber, and for that we need to measure for 5 times. And then finally we are going to measure the required thickness for decreasing the radiation, the gamma radiations, by 3 types of absorber. And for each absorber we need to have at least 8 to 10 thickness. So first of all, for the first measurement, here we have a software. You don't need to do anything with this software. Just when you're ready for your experiment, put the record. So how actually the software works is counting the number of photons per each 30 seconds, and then you have a number. You can record this number. So for background, you shouldn't receive like the high number of photons. That should be average between 4 to 6. So we need 3 replications, and you need to calculate the average of 3 replications, and definitely you need to put your uncertainty in your calculations. In this case, your uncertainty is the second root of your mean for each measurement. So I'm going to put the radioactive source in the right place, So the radioactive source is in place, and then I'm going to have 5 replications for radioactive source. Actually, in that equation, this is equal to N0. This measurement is equal to N0. So it's measured for 30 seconds, and 5 replications. We need 5 replications. So after 30 seconds, we have 130 counts for this sample, and then we again record it another time, and finally 5 times. So the final measurement is measuring the number of count for each thickness. As I said, 8 to 10 thicknesses. So here I have a vernier caliper. The first absorber that I'm going to use is lead, and the reading tell me 2 millimeter. So each of thicknesses is 2 millimeter. I put it on the top of the radioactive source, and then again run the software. So we need to record this data, and then I'm going to increase the thickness and finally have 8 to 10 thickness for each absorber. So now you have the thickness, you have the number of count, and then you can easily plot your graph. In the case of glass and aluminum, the measurement should be same, so you don't need to do any specific things. That only things change is that coefficients, because they are different absorbers, so they absorb the gamma radiations in different level. And final things you need to remember is for your calculations, the gradient of your straight line is your attenuation coefficient. So this measurement gives me 111 counts per sample. Thank you everybody for watching us. I hope this video will be helpful for your measurement and your prac.